All right, today we're diving into something pretty incredible. We're looking at a project where medicine and artificial intelligence come together to do something amazing. Teach a computer how to diagnose brain tumors just by looking at an MRI scan.
So, can an AI really read your brain scan? It sounds like something straight out of science fiction, doesn't it? But as we're about to see, it's becoming very, very real. Let's get into it.
I mean, just take a look at these scans. If you're not a trained radiologist, telling them apart is, well, it's tough. The job here is to figure out if you're looking at a glioma, a meningioma, a pituitary tumor, or hopefully nothing at all. This is a visual puzzle where the stakes couldn't be higher. And that puzzle brings us right to our first section. We're talking about a diagnosis where getting it right, and getting it right fast, is absolutely critical. Let's put a number to this: 24,810. That's not just a statistic. That's the estimated number of new brain cancer cases just in the US for 2023. Every single one of those cases needs a quick and accurate diagnosis to figure out the next step. Right now, the people doing this work are expert radiologists, and they have to manually sift through mountains of these images. It's an unbelievably demanding job. With that much data, you have to wonder, could AI lend a hand? So, how exactly can we get a computer to help? Well, that's what this section is all about: teaching computers to see. And it's not what you might think. We're not giving the computer a textbook on tumors, we're teaching it how to learn on its own. Okay, this slide is super important because it shows a complete flip in how we approach this. The old way, on the left, is classical programming. You give the computer data and a set of strict rules, and it spits out an answer. But with machine learning on the right, you do something different. You give it the data, like thousands of MRIs, and you also give it the answers, the correct diagnoses. And from all that, the computer figures out the rules all by itself. It's a total game changer. The specific tool for this job is something called a convolutional neural network, or a CNN for short. The easiest way to think about it is like a specialized digital brain. It's modeled after our own visual cortex, and it's just naturally really, really good at finding patterns in pictures. And this diagram shows you exactly how that digital brain works. An MRI scan goes in on the left. It then passes through all these hidden layers, which acts like a series of filters. The first layers might just spot basic stuff, like edges or textures. But as you go deeper, the layers start recognizing more complex shapes. Finally, the last layer puts all that information together and makes a prediction: glioma, meningioma, etc. It's like a high-tech assembly line for diagnosis. But here's where it gets really fun. Not all of these digital brains are built the same. So this project didn't just build one AI. Nope. It set up a competition, a kind of AI bake-off, between 4 heavy hitters to see which one was the best for this specific job. So let's meet our 4 contenders. These are all famous, pre-trained models in the computer vision world. Think of them as expert digital apprentices that this project took and retrained specifically to spot brain tumors. First up, on the left, we've got VGG16. We'll call it the veteran because of its classic, straightforward, and really deep design. Then on the right, we have ResNet50, the innovator. It's known for these clever shortcut connections that let it learn incredibly deep patterns. The diagrams look complex, but just think of them as 2 totally different strategies for looking at a picture. And here are the other 2. We've got VGG19, the successor, which is basically a bigger, deeper version of the veteran. And finally, Inception V3, the efficiency expert, which is designed to be super efficient by looking at images at different scales all at once. Again, 4 models, 4 different philosophies. Now, this table really breaks it all down. You can see the VGG models are just massive. We're talking over 130 million parameters, which are like tiny little knobs the AI can tune as it learns. In comparison, ResNet and Inception are way more streamlined. So this sets up the big question. When you're looking for tumors, is bigger actually better? To find out, all 4 models were trained on a huge dataset of over 7,000 brain scans. 80% of those images were the study material. The other 20% was used for validation, kind of like pop quizzes along the way to make sure they were actually learning. Okay, so after all that training and all those pop quizzes, it was time for the final exam. The AIs were tested on a batch of images they had never, ever seen before. So, how did they do? And here we go, the results are in. This bar chart shows the final test scores for accuracy. And you can see it right away, can't you? One of those bars is clearly taller than the others. VGG19 is already looking like our front runner. And when you look at the raw numbers, yep, it confirms what we just saw. The successor, VGG19, just nails it. It hits a stunning 98.48% accuracy. It also scores best on all the other important stuff, like how reliable its predictions are. So why did it win? Well, it seems that for this incredibly complex task, its sheer size and depth allowed it to pick up on the tiny, subtle patterns in the scans that the leaner models might have missed. In this case, it seems bigger really was better.
So there you have it. We have a clear winner. In this particular bake-off, the deeper, more complex VGG19 model proved it was the best apprentice for the job. An incredible result.
Okay, a 98.5% accuracy score is amazing. But what does that actually look like for a doctor in a hospital? That brings us to our final section, taking this from code to the clinic.
The project wrapped up by building a really simple application. It's a 3-step process. A doctor uploads an MRI scan, they click a predict button, and the system uses our winning VGG19 model to give its analysis. Simple as that.
And here it is in action. This is the actual user interface. An image gets uploaded and boom, the system comes back with its prediction, pituitary tumor. This is what it looks like when you take all that mind-bogglingly complex code and turn it into a practical tool that could one day help a doctor. And this quote from the project's own report just sums it all up perfectly. The whole point here isn't to replace doctors. It's to give them a powerful tool, an incredibly accurate second opinion that can take a massive amount of confusing data and make it organized and easy to understand. This project is just an incredible glimpse into what's coming, and it leaves us with a really big question to think about. As this technology gets even better, even more accurate, what does that future partnership between a human doctor and an AI assistant actually look like? What's the next big step?